My name is Shriya Bansal, and today we are going to talk about our next set of problems, which is going to be about algorithm analysis. So far, we've solved a lot of questions. You would have solved a lot of questions, and time and again, when you solve all those questions, it's also important to analyze the algorithms that we write to solve those questions. For a single question, there can exist a lot of algorithms, and according to that, a lot of implementation logics as well. And to compare two different algorithms, we do an analysis and find out their time complexity. I'm sure you must be already knowing about that theory. So what we're going to do today is we're going to take up a few questions, all right? And given the code of that questions, we'll have to analyze their time complexity. So we have two problems today that we are going to discuss, all right? Okay. So let's take up our first problem. The first problem says that you need to compute the time complexity of the given function. Now in this function, you can see there's a function, the name of the function is sum. In that we are passing an integer value n, okay? And this is a recursion implementation, right? That is why you can see that there is a recursive call made in the code to sum n minus 1. If you really look at it, this is simply a logic for adding n numbers, right? So that is why the moment you reach n is equal to 1, you return 1. So as a typical code, this has a base case, this has some recursive calls, and then it has some self work as well. So let's do a proper analysis and see how we can compute the time complexity of the given code. Okay, let's take a look. Now here what we'll do is first we'll write down the function again and then do the proper analysis. So if I have a function sum and I am passing a value n to it, this is our first question. We say that if at any point of time the value of n becomes 1, we also return 1. Otherwise, what do we do over here? We basically return n plus sum minus 1. Okay, so this in our code will be the base case. This will be the recursive call to the smaller problem, and this will be the self work. And as you know, for solving any problem, the best way to do that is specifically for questions on recursion is to find out the recurrence relation and then try to solve it and find out the total time complexity for that implementation. So for defining any recurrence relation, we use T of n, where n is the input that is being passed to this function, right? So what you can do is, this base case is nothing but a constant operation, right? Adding this number to this is also a constant operation. So the recurrence relation can be this, correct? I hope this makes sense. This one is pretty easy. We are doing a few constant operations, so that's why I have added a 1 for it, right? And the t minus 1 is for because we are making a recursive call to the problem for n minus 1. Okay. Now with this, we can find out the value of t n minus 1 as well, substituting n with n minus 1, okay? And that will give me 1, right? And this will give me t of n minus 2, correct? And now if I will take this value of n minus 1 and substitute it back over here, I will get t of n is equal to 1 plus this value placed for this, that is 1 plus t of n minus 2, which is nothing but t of n is equal to 2 plus t of n minus 2. So the other way of writing this equation is going to be this. First wave was this, second wave was this. Similarly, if you will try to find out the third way of writing the equation, it will be 3 plus t n minus 3. Follow the similar way. Try to substitute the value of n minus 2 instead of n, right? And then whatever value you get, equate it back to tn minus 2. And this is what you will get from there. So with these three equations in mind, if I have to generalize this concept, it will be k plus t of n minus k, correct? that would be the general equation over here. Okay, what does that mean over here is that here we have 3, so hence here we had n minus 3, right? Here we had 2, hence we had n minus 2 over here, right? Similarly, we had 1 over here, and with that we have t of n minus 1, correct? So what we are essentially doing over here is that we are doing this equation, and as you can see, the general part of the equation is that this k is definitely nothing but a constant value, right? And apart from that, we have a n minus 1 to it, correct? I hope everyone is clear so far. So now we have to solve this part, right? So what you will realize is that with different equations being added, the value of this part is decreasing, right? First it was n minus 1, then it was n minus 2, then it was n minus 3, right? So at some point of time, what will happen is this value will depreciate and it will become to 1, correct? And based on that, the value of k I can say is n minus 1, right? Now what I will do is I will substitute the value of k back here, and that will give me t of n minus 1 plus t of k value is what? N minus 1, correct? And over here we will have n minus 1 plus this cancels out, t of 1. T of 1 is again constant, you can consider it 0, and hence in the end the overall complexity is what? N minus 1 plus t of 1. This can be ignored, this minus 1 can be ignored, and hence the total complexity is going to be O of n. Clear to everyone? I hope this helps you to understand how the complexity is being derived. Okay, so this is how we are basically going to solve our question. Remember, t of 1 is 1. Okay, so when you substitute the value of t of 1 to 1, even this minus 1 cancels out with this. So we are only left with a n, which is the complexity for this particular question, and that makes sense as well, right? Because we are finding the sum of n numbers through recursion, so it should ideally take a complexity of O of n to solve this. Okay, now let's take a look at the second problem statement as well. So in the second problem statement, what is happening is you are given two variables, a equal to 0 and b equal to 0, and then there are two nested loops. So let's see, here we have let a equal to 0 and then we have b equal to 0. Then we have two nested loops inside it with two different variables acting on both the loops. So let's, for I equal to 0, I is n, I plus plus, and similar to that inside it we have, for let j equal to 0, j is less than n, and then j plus plus. And what we are doing inside this is that we are simply adding the value of j to this variable a. Okay, so this is nothing but a is equal to a plus j, right? And that is it. There is nothing else that we are doing inside this loop. Okay, then there is another parallel loop with the I loop, which is the outside loop, right? Which is what doing is it is having again going through the value till n. Okay, and now it is making use of the second variable b and basically adding the value of k to it. So it is basically doing b is equal to b plus k, right? And now for this code you have to compute its time complexity. So you can see this is a simple nested for loop, correct? And thus the overall complexity will be O of n square, right? Because for each value of n we are iterating n more times inside it. Okay, and with that we have this, which is again a parallel loop to the outside given loop, which is having the complexity of O of n, which is again pretty simple because we are starting with 0 and we are going up till n, right? And now to calculate and compute the total complexity of this approach, it will be nothing but, So when you have two parallel ones, right, two parallel loops, you basically always take the maximum of those and then try to find the complexity. Okay, so what will happen over here is we have we have O of n square, okay, and then we have O of n, right? So although we do have a O of n loop over here, but the one which is the major factor over here is O of n square, and out of O of n square and O of n, we already know that O of n square is maximum. Hence the total complexity for this code is going to be this. Clear to everyone? I hope this helps you to understand how we are solving these questions. Alright, again, the very important part here is how you analyze the problem, right? What basic rules do you know about the concepts of time and space complexity, and then you try to implement it and solve the question. Okay, so it's very important that you know when to add two different, I would say, bigger notations, when to multiply them, right? For recursion questions, you need to understand that recurrence is something that we take into consideration, and then we solve the questions. All right, so I hope I was helpful and in helping you solve all these questions, and I will definitely see you in the next one. Thank you.